In this section, we are looking at differential capacitors and how that can be used to make sensors. So there are a lot of advantages of having sensors that are differential. So for example, in this case, you have this kind of an arrangement where there are two capacitors. One of the capacitors is formed by these two plates, and another capacitor is formed by this plate and this plate. So the center plate is common between two capacitors. Now, if you have a displacement of the center plate, the capacitance of one of the plates is going to increase while the other is going to decrease. So C1 can be written as will have a inverse relationship to D plus Z, while C2 is dependent on D minus Z. And this essentially helps us to make better and more sensitive sensors. Let's take a look how. So what we can do is, in this particular circuit, since we have the equations for C1 and C2, we can use that to write the equations for V1 and V2. And if we write the equations for V1 and V2, we have these equations. And substituting the values of C1 and C2, we can get V1 as VR d plus Z over 2t and V2 as VR d minus Z over 2t. If you can use these two outputs and take a difference of these two outputs, what we see is we get a linear dependence of the displacement on the output. And therefore, we have a linear output and also we have greater sensitivity. And those are the two advantages of differential capacitors. Now, there are various kinds of differential sensors that you can have. So differential sensors need not only be dependent on the displacement, but like in this case, as this plate of the capacitor moves, the area of overlap between this capacitor and this capacitor changes, and therefore you have a differential capacitor which is formed by the change in area. And a similar thing happens in this sensor as well. One very interesting example of a differential capacitor is a sensor here, which is a capacitive carbon dioxide sensor. Now, this sensor is basically based on the movement of this diaphragm here. As this diaphragm moves up and down, the two capacitances change, and that gives you different outputs. Okay. Now the diaphragm moves up and down depending on the two chambers S and R. If the pressure in the chamber R is higher, the diaphragm moves upwards. If it is lower, the diaphragm moves lower. Okay. Both these chambers S and R are filled with carbon dioxide, and they are illuminated with infrared light. And depending on the infrared light on both of them, impinging on both these chambers, the carbon dioxide absorbs the infrared energy and gets hotter, and therefore the pressure in these two chambers changes. If the same amount of light is falling on both the chambers, the pressure is equal, which means that the diaphragm stays at the center without moving. Now what we do is we let light fall on one of these chambers unimpeded, and in another of these chambers what we do is we put a beaker of the carbon dioxide that we want to measure, the amount of carbon dioxide. We want to measure the amount of carbon dioxide in this beaker. So when the infrared light starts to travel, here it just reaches whatever infrared light is sent, reaches this chamber. But in this case, there is some carbon dioxide inside this tube, so that absorbs some of the infrared light, and the rest of the infrared light falls here. So this chamber receives less infrared light compared to this, and therefore the pressure here is higher, and therefore the diaphragm moves up, and therefore the differential capacitor starts to work, and we can sense the change in the capacity here. So this is a very interesting example of how Starting from a differential capacitor, you can make a reasonably complicated carbon dioxide sensor. Of course, you do not want the infrared light to fall on these chambers for a very long duration of time, because the temperatures would rise very high. Therefore, there is this motor here which makes sure that the infrared light only falls very intermittently on these chambers. And over a long period of time, the pressure between these two chambers equalizes, because there is a small hole in the diaphragm that allows such equalization to happen.